right, so vertical angles. They are opposite angles formed by intersecting lines. And remember that they are congruent, meaning they have the same exact measure. So your picture, remember they're completely opposite from each other. So they're right across that vertex. Okay. Adjacent angles are two angles with a common vertex and a common side. And they look like this. Remember that they are side by side. So if I drew a picture like this, my adjacent angle would be A and then say C. So these two angles right here would be adjacent. So they're side by side. Okay. Supplementary angles. Remember that those are two angles that add up to 180. So together they make a straight line. Supplementary, 180. Complementary, they add up to 90. So remember, this is a right angle. And it's split into two different angles. So those two angles form a 90-degree angle. But they add up to give you 90. An acute angle is an angle whose measure is less than 90. And then remember, a right angle is 90 degrees. And a straight angle is 180 degrees. Any questions on 1 through 7 definitions? I need to go back to any of them. Yes, ma'am. Vertical are opposite angles formed by two intersecting lines, and they have the same measures. Adjacent angles are two angles with a common vertex and a common side. And supplementary, two angles that add up to 180. Good? All right, number 8, an obtuse angle. Remember, that is any angle greater than 90. A scalene triangle has a triangle with three sides that are not congruent. So all three sides of this triangle are not the same. So I could have 2, 3, and 4. Okay. An isosceles is a triangle with two congruent sides. So remember, these two tick marks right here tell me that those two sides are the exact same length. And then an equilateral triangle is a triangle with all three congruent sides. So all three sides are the same exact measure. And then an obtuse triangle, that is a triangle with one obtuse angle. An acute triangle is an acute with three acute angles, so all angles are less than 90 degrees. And then a right triangle is a triangle with one 90-degree angle. Any questions on those? So we're good on all the definitions so far. Okay. Number 15 says an artist is using right triangles in her design. If each triangle has one angle that's 32 degrees, what is the measure of the third angle? So if it's a right triangle, remember that it has one angle that's 90 degrees. So I think it's a little bit easier to go ahead and draw a picture if you need to. So if you were to draw a picture, you know that this is a right triangle. And then they tell you that one of the measures is 32 degrees. Zoom up a little bit. So then that means you're trying to find this other side. So x. So that means you have 90 plus 32 plus x equals 180. Add your 90 and your 32 and you get 122 plus x equals 180. And then you have a one-step equation. So you're subtracting 122 from both sides and x equals 58. So if you need to draw a picture first to help you figure it out, that's fine. Does anybody have a question on that problem? All right, flip over. Number 16, we are finding the value of y. So remember, all three angles of a triangle have to add up to what? 180. So that means 42 plus x plus 90 has to equal 180. So you write your equation, and then you combine like terms. So 42 plus 90 gives me 132. And then subtract that 132 from both sides, and x is equal to 48 degrees. Sierra? Yes. Sorry. You have to remember that all three angles of a triangle add up to 180. You're doing the exact same thing for number 17, except you have x's in there. So remember, it's going to be 3x plus 6x plus x equals 180. All of these terms are like terms. They all have an x in them. So that means I can add their coefficients. So 3 plus 6 is 9, plus 1, remember that's a 1x, is 10. So I have 10x equals 180. And then divide both sides by 10 to give you x equals 18. Any questions on that one? So you got to remember that since these all have that x term in there, you can add them. And you have to remember that that x is a 1x. There's a 1 in front of that. Any questions? Okay. Number 18, is it possible for a triangle to have a 25-degree angle, a 30-degree angle, and a 115-degree angle? So remember, this is our, like what we did on the triangle inequality lab last Friday. Two of the sides have to add up to be larger than that one side, than the largest side. So, first of all, though, you've got to make sure that they all add up to 180, right? So if I have 25 plus 30 plus 115, does that equal 180? No, because all of that is actually equal to 170. So I know that I don't even have to go as far to add up the two sides and see if they're larger. All I have to do is make sure that they're at 180, and they are not. So it is not a triangle.
I think she taught us something like, could you add up the lowest number and it was greater?
That's what I'm talking. That's like how our triangle inequality theorem was. So if 25 plus 30, that would give you 55. If that was greater than 115, then it would be a triangle, but it's not. So it's still no. But this is another way that you can do it as well, because you know that they all have to add up to 180. So they don't. So I know that it's not a triangle. Any questions on that one? We're good? Okay. Number 19, is it possible for a triangle to have the following side lengths? 24, 36, and 14. So this is like what you were just asking about, Sierra. You can add up those two smaller sides, and if they are greater than the larger side, then it's a triangle. So in this case, I have 14 plus 24, which gives me 38. 38 is greater than 36, so that means that it can be a triangle. So if you add up those two smaller sides, and they add up to be greater than the largest side, then it is a triangle. So your explanation, yes, because the sum of sides 1 and 2 is greater than side 3. That's like the triangle inequality lab. Any questions on that one? So that's exactly like the next one. Is it possible to have a triangle with 2, 2, and 3? So first, this would be side 1, side 2, and side 3. So if I add up side 1 and side 2, 2 plus 2 is 4. Is that greater than 3? Yes. So that means that it is a triangle, because the sum of sides 1 and 2 is greater than side 3. You need to know how to explain this. On your test tomorrow, if it says to explain it, then I need you to tell me, why is it a triangle? Okay. Any questions on that so far? All right, 21 through 23, you're finding the area of a triangle. So somebody remind me what the formula for an area of a triangle is. Harper. Good. Area equals 1/2 times base times height. So if you are given a triangle that looks like this, which one is my base? 12. Which one is the height? 9. Okay. So you have 1/2 base times height. So 1/2 times 12 times 9. And once you multiply all those together, you get 54. You have to remember that it's in inches squared. So on your answer, it needs to have your units right there. Area is always squared, so it's inches squared. No, I don't think I told you that when we were working out that problem. So make sure that you have 54 inches squared. Okay. So number 22, you are finding the area as well. So this is not part of the triangle. So the triangle is actually this right here. But this is just telling you that the height of the triangle is 30 yards. So this is your height. And then this is still your base right here. Okay. So 1/2 base times height. So that means 1/2 times 20 times 30. When you multiply those together, you get 300 yards squared. We good on area? What about when it's given to you in a word problem like number 23? So in this case, they told me that the area of the triangle is 150 meters squared. The height was 20 meters. They wanted to know what the base is. So if I start out with my original equation right here, area equals 1/2 base times height. Area was 150, so I'm plugging 150 in for A. And then I still have my 1/2. My base is what I'm trying to find, so I'm keeping that as a B. And then they told me that the height was 20. So when you combine your like terms over here, you multiply 1/2 times 20, you get 10. So 10B equals 150. And then you're solving for B. So you're dividing both sides by 10, and you get 15 equals B. So the base is 15 meters. Questions on that? So if it gives you your area, you've got to plug in that number for A. So you got to pay attention to what information they're giving you. Don't just assume that the two numbers that they give you are the base and the height. You've got to read the problem and find out which is which. Sierra. Yes, only if area. Area is the only thing that your units will be squared. Your base and your height will just be inches, yards, feet, whatever. Area is the only one that is units squared. Questions on that page? Okay, flip over. Number 24, we are classifying the triangle in number 21. So, this is the triangle we're looking at. What type of triangle is this? Remember, we classify it by side lengths and by angles. So, Nick, what is that? Isosceles. What type of isosceles? Acute. This right angle, don't let that throw you off, because that's the inside of a triangle. The triangle is this whole thing right here. So all of those angles are acute angles. So this would be an acute isosceles triangle, because these two sides are congruent, so it's isosceles. All the angles are acute. And then number 25, we're looking at the triangle in number 22. So remember, this is your actual triangle, not the dotted line part. So what type of triangle would this be? Obtuse what? Obtuse scalene. It's scalene because none of the sides are congruent. And it's obtuse because this angle right here is obtuse. Okay. Does that make sense? So it's an obtuse scalene triangle. Okay, number 26 says to classify the pair of angles, find the value of x. So somebody tell me what type of angles those are first. Alexa. Supplementary. So that means that they form this straight line right here. So what do these two have to add up to equal? 180, because supplementary angles add up to 180. So that means I have 110 plus 2x equals 180. And then you subtract 10 from both sides and divide both sides by 2, and x is equal to 35. Okay, number 27. Classify the angles below and find the value of x as well. So these together form this right angle. So that tells me that it's complementary. So the two add up together to make 90. So 3x plus 4x minus 20 equals 90. Remember that the only like terms I have here are 3x and 4x. So I can add 3x plus 4x to give me 7x, and then I still have that minus 20 equals 90. So then add 20 to both sides and divide both sides by 7, and you get x equals 110 over 7. Questions on that one? We good? Y'all don't have any questions? Okay, number 28, classify the angles. These are completely opposite. They share that vertex, so they are vertical. And then vertical angles, remember, they have the same measure. So I can say 102 equals x minus 5. And then you solve the equation. So add 5 to both sides, and x is equal to 107. Number 29, name the angle below in 4 different ways. So, remember, you can name it by just the vertex, so angle W. You can name it with all 3 points, so U, W, X. Or you can do it opposite, X, W, U. And then you can also name it by that number, so angle 6. And then number 30 is asking you to classify this angle. So what type of angle is this? Acute. What type of angle is number 31? Straight. What about 32? Obtuse. It's greater than 90. Okay, number 33. Classify the angles. I told you wrong. These 2 angles together are acute angles, right? But together they're side by side, so that tells me that they're adjacent. So those are adjacent angles. What type of triangle is number 34? Good. Acute equilateral. These tick marks tell me that all 4 sides are the same. And then each angle is an acute angle. So it's an acute equilateral triangle. Number 35, what is that? Good. Obtuse isosceles. So this angle right here is obtuse. Both of these 2 sides are the same, so it's obtuse isosceles. And then number 36, what is that? Right scalene. Good. It's a right triangle because of that little square right there. And then none of the sides are equal. So it's a right scalene triangle. Any questions on that back page? Okay. Did anybody get the... Did anybody do the back?
No.
I did, but I didn't do it.
Okay. We'll go over it real quick, since we have about 5 minutes. Number 1, the figure formed by 2 rays with the same endpoint is an angle. The basic unit by which angles are measured is the degrees. So angles are always measured in degrees. The intersection of 2 sides of an angle is called the angle's vertex. So remember, that's where 2 angles meet. The small box at the vertex of AOB and angle AOB indicates that angle AOB is what? 90 degrees. An angle with the measure of 90 degrees is called a right angle. Point C, right here, is the interior of angle BOD, which we didn't really go over that. An angle whose measure is between 90 and 180, that would be an obtuse angle. 2 angles whose measures have the sum of 90 are complementary. If you look in the picture up here, angle BOC and angle BOA, those are side by side, so they are adjacent. Letter N, two angles whose measure have a sum of 180 are supplementary. An angle whose measure is between 0 and 90 is an acute angle. It's looking for angles that are supplementary. So if we look at AOE, that means it has to be EOD because that's the only way that those form a straight line. They're supplementary, they form a straight line. And then angle COD and angle BOC are complementary angles, meaning that they add up to 90. Two angles having the same measure are said to be congruent. Congruent means same. Angle COD and angle AOE are congruent because they are vertical angles. You have to remember that. Vertical angles have the same measure. And then the two rays that form an angle are called the sides of an angle. This? No. All right, any questions? When is our test?
Tomorrow.
Tomorrow.